Hello students, relax, sit back and listen to our math class. In today's class, we are going to learn the concept symmetric and skew-symmetric matrix. Symmetric matrix means it will satisfy the condition A equal to A transpose. Whereas skew-symmetric matrix means it will satisfy the condition A transpose equal to minus A, where this A is the given matrix. So, symmetric matrix, a square matrix A is said to be symmetric if A transpose equal to A. So, if you are taking a square matrix and if the square matrix is symmetric means then that matrix transpose equal to the original matrix. For example, here a matrix is given. This is a square matrix, 3 rows and 3 columns. The values are 3, minus 6, 9, minus 6, 8, 5, 9, 5, 2. We have to check whether this matrix is a symmetric matrix or not. If you are taking transpose of this matrix means A transpose equal to columns will be written in the place of rows. So 3 minus 6 9, this column minus 6 8 5 as minus 6 8 5 and 9 5 2 as 9 5 2. So here this A matrix and A transpose is similar to each other. So this is a symmetric matrix. Whereas skew-symmetric matrix means a square matrix A is said to be skew-symmetric if A transpose equal to minus of that A. Consider this matrix, we can check whether this is a skew-symmetric matrix or not. The given condition is A transpose equal to minus A. So if I am taking transpose of this matrix, what I will get? A transpose equal to column 0 minus 2 3. So 0 minus 2 minus 3. 2 0 minus 4, 2 0 minus 4, 3 4 0, 3 4 0. This A transpose equal to minus of A. Am I right? Because here 0, 2, 3 are positive. Here 0 minus 2 minus 3 negative. Minus 2 0 4. Here the signs are changing in these two matrices. So this will be equal to, if I am taking minus as outside, then 0, 2, 3, it will become minus 2, 0, 4, minus 3, minus 4, 0, which is equal to minus of A. So here A transpose equal to minus of A. So this matrix is a skew-symmetric matrix. Thank you for watching. Subscribe to our channel for more videos related to both school and college maths. Thank you.